All right, we're going to apply some triangle congruences, specifically either, in this case, angle side angle or angle angle side, and we can use angle side angle as well as angle angle side to prove congruency of remaining angles or sides as the case may be. All right, so here we got this sign, this road sign. It looks, I've seen signs like this on the road before. Maybe you will have too if you've paid attention. And if you're not driving yet, you'll pay more attention to these things a little bit later, but let's get started on what we have here. All right, in the sign shown on the right, segment BC, all right, I see BC there. It's perpendicular to AC, and segment DE is perpendicular to CE. Now, one of the ways we know that it's perpendicular is this right angle right here, because if two lines intersect at a right angle, they are perpendicular. Okay, let's go on with our givens. Angle BAC, and I see a little congruency tick mark right here at A. Remember, order is important. When we're talking about angles, if it's described this way, the letter in the middle is at the vertex. That's congruent to DCE, and shazam, I see congruency there. So I got angle, angle. Those are congruent. What about side? Well, how about this? Segment AB, and I see the congruency tick mark, is congruent to segment CD. Angle, angle, side. Angle, angle, side. I'm looking pretty good. Write a paragraph proof to show that BC, segment BC, is congruent to segment DE. So why don't we get started? All right, we're given, always listing our givens first, that segment BC is perpendicular to segment AC, that segment DE is perpendicular to segment CE, and then that angle BAC is congruent to angle DCE, and that segment AB is congruent to CD. We're just restating our givens. Now let's start working our way through the proofs to get to a good conclusion to prove that segment BC, look carefully, is congruent to segment DE. All right, now, since segment BC is perpendicular to segment AC, and segment DE is perpendicular to segment CE, angles BC, C's the vertex in this, see that right angle, A, is congruent to angle DE, E's the vertex, C. And as we said, they're right angles. They're right angles because we're told that they are perpendicular. Those two segments are, those actually four segments, but two on each triangle, are right angles. All right, let's keep going. All right, so then angle BCA, which we just talked about before as a right angle, is congruent to angle DEC because guess what? Believe it or not, all right angles are congruent to each other because they're 90 degrees. They got to be congruent, right? All right, let's see. So we got that. So we got that angle. So then by angle, angle, side, by that postulate, angle, angle, side, triangle BAC is congruent to triangle DCE. And now we're ready to finish off with our proof statement. So BC must be congruent, segment BC must be congruent to segment DE by CP CTC. And what does CP CTC stand for? Congruent parts of congruent triangles are congruent. So if I've got two angles and a side, angle, angle, side, angle, angle, side, and I know that they're all congruent, then the remaining side and, in fact, the remaining angle must also be congruent. by congruent parts of congruent triangles are congruent. CP, CTC. How about that?